Yeah, thanks everybody for having me. Like I already said, we go way back a little through various meetups, and I'm super happy to be here. It's actually my first ever conference talk. I've just talked on meetups before, so I'm kind of nervous, but yeah, it's a personal milestone. So thank you very much. And I have prepared lots of slides. I hope he wrote in this email like you can finish people off for the lunch, so it's maybe too tired to eat. But I hope you'll come out with happy faces to get from this talk. And we are talking a lot about code. We are going a lot more into detail. Like we're not talking on a conceptual level as much as we did in the previous talks. And so I'm in the Preact team. And or maybe you should go back and start a bit on my tracks. This is my Twitter handle. I unfortunately had to cut off the last 2 letters. My name is too long for Twitter, like typical German fashion. And I'm a web developer for 8 years. I mostly deal with enterprise software, so I'm currently employed at Awesome Software, which is a consulting agency, meaning you can book me and help you out in your projects. And typically the clients are enterprise, so think of like insurances, banks, automotive industries like Mercedes and all that stuff. And so like there's huge wrath of legacy software and everything. And so I kind of need like a hobby where I can do cool shit. And this is Preact. I'm in the Preact team. We'll go into a little bit detail into later what this means. And having that background in the enterprise world kind of made me obsessed with simplicity, which naturally fits into Preact. So yeah, Preact, what is it? Well, it's a 3 kilobyte alternative to React. It has the same API. You can literally name drop it and do a Webpack LES, and boom, your app is running in Preact. And what's special about it is that we've built the whole framework in 3 kilobytes, which is insane if you think about it, because like 3 kilobytes is nothing. Like how can you put so many features into 3 kilobytes? And we're going to lift the curtain in this talk and talk a bit about how we approach problems, how we actually do code, because it's more of a cultural aspect. It's a bit less about the technicalities of doing code. And we're going to see what this means. So the magic 3 kilobyte limit is in all our marketing materials, and this is for a very good reason, because Preact has never been bigger. It has always stayed in the same range, despite us adding new features with each version, despite like the world is changing. We all know that frameworks change over time, so we have to adapt and stay relevant in the market. And yet, through all this time, we always has hovered around 3 kilobytes. Sometimes it's 3.2, 3.6, but it never goes up to 4. We always have a 3 in front of it. And this is, I should also fairly say, this number is from the minified Gzip compressed file. This is not the uncompressed version. It's the limit that you will see when you ship Preact out to the browser and download it. So we just released our major new version called Preact X. It's just, I think it's like 2 or 3 weeks ago now. And we shipped lots of new features. Fragments, which is basically a way to wrap components and have their wrapper components where you can wrap all your code, and just they're transparent for the DOM. They won't render anything out. It's kind of like to work against the limitation of JSX, where you always need a top level root node. We also added component catch, which is a way to catch of course we all write good code, but sometimes we don't. And this is where you love to have good error handling, and component catch allows you to catch not just errors in your it won't allow you to catch errors in your application logic, but it allows you to catch errors during the render phase. And we also added support for CSS custom properties. They kind of worked before, but now we have fully support for them. This is pretty important because Jason, the inventor of Preact, he works at Google, so he has to make sure that they stay ahead of the curve and always add the latest and greatest features. And we, of course, added hooks. Like once React announced it, that they are working on hooks and they are publicly available, we got an issue like 10 minutes after that. So and we also had a prototype ready in half an hour, but if we would have released it, like everybody would have gotten out their pitchforks, because like as prototypes are, they're pretty buggy. But we released it now. There's one thing to note: it doesn't count into the 3 kilobyte limit right now. It's an add-on. It's separate. But the thing is, with Preact, we have like an option system where we can hook various renderers into our renderer, various plugins, various add-ons, and hooks is one of those. And we are now looking to bring that into core, into the same 3 kilobyte limit. But we will need to take a bit more time of that. It just doesn't happen with one finger. All right, size difference. Previous version of Preact is called 8. Yet there is a version jump. It was mainly we intended to have a migration release in between where we could say it would just have the breaking changes, no new features, so that people can easily migrate. But then it turned out that everybody jumped right to the 10 version. So we said, okay, we're a small team, so maybe it's better for us if we just skip that version. And the new version, Preact X, is actually the same size. With all the features that were just present on the previous slide, it's the same size. So what happened? Like, the natural question that we get is like, how the hell is this possible? How can you take the thinnest JavaScript library and make it even thinner? And which is ridiculous, but it works. And this is basically the topic of this talk. And so, how do we get small and keep adding features, and we kind of get away with it? So first, is the cultural aspect. Like, we are obsessed with simplicity. This doesn't mean, or I should say, in the earlier parts of my career, I started out developing in the front-end world, and I always was like dumbfounded by my senior developers on my team. Like, they wrote such simple code. Why are they getting paid so much? And the honest truth is, it took me a while to realize they were getting paid so much because they could take complex things and make them so obvious and simple that everybody could work on it. Which is like a very, very valuable skill in our industry. And simplicity is, it's something that is a set of mind. Like, you have to watch out for it. You have to nudge your head against the problem, like we've seen in the previous talk, to be able to come up with better solutions. And the thing is, simplicity is not familiarity. Many people think, especially in the enterprise world, I've been doing it for 10 or more years, like all these weird steps. And it's simple for me because I can recite all steps by hand. But if you come with a new person and you would see at all these steps and look at it and say, holy crap, this is hella complex. But because they've internalized it, it seems simple to them, although it isn't in reality. So do not confuse these two, because familiar things are actually complex things in disguise. This is very, very true. I see this all the time in the enterprise world. Like, there's these huge legacy systems, but because it's easy for him because he's doing it for 10 years, but it's a mess for everybody else to work with. So very, very important. And of course, everybody thinks like, oh, you do like secret tricks and nobody knows about, like JavaScript tricks and code golfing. We'll get into that, but the honest truth is, like, code golfing, it only gives you like 10% of savings. The big savings don't come from code golfing or from trying to manually minify your code. The big savings come from better architecture. Is the micro still working, or like, all right? So the thing is about architecture, once you think about your architecture and how you can shape it in ways that is easier for the program, it will also lead to less repeated code. And this in turn will usually feed back into the architecture, making the whole system simpler. So there's always this loop, which is like never-ending loop, and will always like, it won't stop. It will never stop as long as you keep adding features or keep nudging your head against the problem. So very important. But what does it all mean? Like, we talked a little bit about concepts, but how can I translate this knowledge into my code? And to get into that, I think it would be a great idea, like how we made the jump from Preact 8 to 10, disregard the 9 version. And the main difference in architecture is that Preact 8 diffed its virtual structure, like the thing when you return, when you write JSX, you're actually creating many little objects, and we typically call them vnode for virtual DOM node. And we diffed it right against the actual DOM that could be found in the browser. This has several side effects. Like, this is an example. The left side is something that would be returned from your JSX from create element. You can see, like, you have a node name. It's a div in this example. It has a simple class called foo, and it has no children. So it's basically just a div with some styling purposes. On the right side is a DOM element where I just did console.div, and this is what you get in Chrome DevTools or any other DevTools for that matter. And you can already see there are some differences, like the attributes are not just an object, they're a special kind of class, which is a named node map. And also the DOM children have a different class, so there's already a mismatch between these two objects. You cannot compare them one by one, or you have to do some normalizing stuff before you can actually compare them, which is a huge problem once you're thinking about our size limit, because normalizing stuff or having to write code which normalizes stuff means we have to spend bytes on that, and this is bad for us, no? So what we essentially did was we were comparing apples against oranges. I had some pretty pictures there, but then Google Docs screwed up. Like, I think the emoji support is still somewhat beta. So I just replaced it with some slides. So the circles, the red ones are apples, and the orange one are oranges, obviously. And we also have like a C for a component there, and then the trouble with diffing against the DOM is like, what should we diff the components against? Like, there's of course there are web components, but components in React or in Preact are a different kind of abstraction. They don't map one-to-one. So we did a very ugly hack. We basically in Preact 8 we said, okay, we have all DOM nodes, and on a DOM node we have a property underscore component where we store the component definition. So we'd always look if there is a component property on the DOM node, diff against that, and only after that diff against the actual DOM node. But this in turn also means we have like two ways of traversing the tree. One is via the standard DOM nodes, and the other way is via this component property. It was like a huge clusterfuck. It was not pretty. And it's also an area where I just look at the GitHub so and she's like, how could this ever have worked? Like, I have no clue, but it somehow did. So yeah, so we needed to change that. So it was like, yeah, it somehow worked, but nobody knows how. What does it mean if you look at the code? This is an example where we diff a text element, and maybe you have like hello world text, and we check first like, okay, there's already a text node, so we just need to update the text value. And the thing is, because we're diffing a virtual, like standard JavaScript object against an HTML element, we have to check for, we did this ugly way of checking if it is a text node by checking if it has a split text property on the DOM. Normally we'd use like instance of text or something, but this compressed better in our scenario for Gzip, and just change the node value then. If it wasn't a text node, like maybe creating a new text or something, we need to create it, and we of course need to add it to the parent somewhere. And this little part we will get into it later. It was kind of like an optimization that can be found in game engines, which we completely got rid of, but we'll talk about it later. So what changed in Preact 10? In Preact 10 we now compare apples to apples. We compare virtual nodes to virtual nodes. This means we have two copies of your app in memory. Like, one is the current one and the other one is the previous one, and once you do a new render, like the current one becomes the previous one and the previous one will be discarded and taken care of by the garbage collector. So we always have these two trees in memory, and this makes comparison a lot easier, because now you don't have to do some weird shenanigans like, is this really a text node or is this really something else? You just know, okay, it's this node. So it's the same, right? You can just, it's a lot easier to compare. You can just say, is the type the same? Is props the same? Is class the same? Are children the same? Super easy and compresses really well. So this is great. And of course, it's a lot easier even for components, because now components, we can actually diff them against something. We don't have to do any shenanigans where we access a special property and kind of have like this whole separate world of different components. No, it's the same thing, which is really cool and makes a lot of code. It uses a lot of code. Remember the previous text example, which was kind of rather long. This is the exact same code in Preact X. We just have like a simple if case. Like, if in our case, when the type property is null, this means we have a text node. And we just check, all right, if we have a DOM node already, if we don't have a DOM node, we just create one, boom, done. And if we have a DOM node, we just change the text. And that's pretty much it. Like, it's just a simple if statement. And if we take them side by side, you see the difference in, like, just let that sink in, because it does the same thing, which is kind of ridiculous when you think about it. But it's one way because we simplified our architecture. We're not diffing against the DOM anymore. We're diffing the same data structures. And this architecture allowed huge savings. Imagine this kind of saving for every other feature that we have, which is amazing. So we got Preact a lot smaller. I have a slide later about this. So, I I've screwed up the numbering. But code branches are basically like, I think they are evil, because code branches or any form of control flow leads to complexity. And so you have to be very careful and conscious about introducing another if statement and introducing another form of control flow, because this leads to complexity. More complexity leads to less easy to work with code base, makes it hard for your coworkers, etc., etc., etc. There are huge consequences. And every action has a cost, so be very conscious about introducing just another if statement. Like in React components, the classic example is like, should it take an array of strings? Should it take just strings? Always take an array, right? Don't make another if case just for the single case. Make it one case. Always use an array. So these little things can add up really easy, because it's especially true in legacy software. It always starts with us like, just all right, let's just add an if statement here. Let's just add a workaround here or anything, and like. All these little steps seem fine, but in the long run, if you look at the whole picture, it's a mess. And this is all these little steps that have led to this path. So be very careful. And another thing to get this point through is like, we don't have function components actually. They're a trick. Because you can use them, you can write a simple function, but the first thing that we do in our code base is turn them into a class. And this is for the same reason, like I said earlier, to reduce the number of if cases. Because if it's just the same data structure, you can push it through the same functions and it will work. Like we do not have a second code path just to skip life cycles like component did mount or anything. We don't need that. We just have like the same data structure, so we can put it through the same functions. So this makes our code simpler. Like, of course, you need to do some trickery with just setting the constructor and stuff like that to make it work, but it works and it's pretty fast. Like there's a super tiny performance penalty for doing that, but we make up for it in our render code because our render is highly optimized. So in the end, it kind of evens out. So yeah, which is kind of cool. All right, so yeah, this is the case. If you detect that we already have a class, we just make an instance. And if you say, all right, you don't have a class, we just say, okay, the constructor is your function, and we put in a special render function, which kind of just calls the constructor. All right, so normalize your data. Super, super important. I think like even in bigger systems, I mean, Preact is just a library. Even in bigger systems, normalize the data before it comes into your code. Because like imagine your code is like a circle, and the outer layer is the normalization layer. This makes everything easier. Because your code can now be simple, and your app at the core it can be free of a lot of if statements, a lot of workarounds if you have the normalization layer at the outside. Push it as far as possible to the outside. So you saw in the text example, you saw an early example of, I think, recollect node tree or something. This was a feature we called the component recycler. We had it in Preact 8 and it was a mess, honestly. It's the funny thing is, even in our 3 kilobyte size, we have technical debt. Like we wanted to get rid of it. This is hilarious, but yeah, every app kind of has technical debt. So the component recycler is an optimization that's very present in every game engine or in every game, because the idea is basically, instead of always recreating new objects, remember you're storing 2 DOM trees in memory, instead of always recreating them or recreating DOM nodes, we can just cache the node. And once we see, all right, we need to render the same component again, we just pull out the node, so we do not have to recreate it and just can keep it in memory. The important part is that you have to reset properties. Like imagine, like we will walk through this step by step. So here's a DOM node, which in turn turns into, this is a JSX code, which in turn will turn to this object, and we have a pointer there called DOM, where we store the reference to the actual HTML element. So, all right. So the first step, of course, you render your component summary. In this case, it's very creatively called foobar. It just renders a div node. It's just for example purposes, and you need to render it pretty quickly. And sometimes later it's not used anymore. Maybe you switched pages, you're going to a new URL in your app or anything. Make sure not to use hashes, like we learned. And so we could just say, okay, now we need to destroy this component, but instead of like just we're moving them from the tree and letting the garbage collector take care of it. We just store it in a sort of a cache or a pool. It's another word you can find for it. And once you need to render another instance of a full-buried component, this is called its version 2, we just pull out the node again and assign it. And you just need to reparent it in the tree, like to put it in the right place in the DOM so that it all works out. But the big problem is DOM nodes are stateful. Think of an input element. Like you need to be very, very careful to reset all properties. Otherwise, like you have like weird shenanigans where this input from the other area, like this text will be in the other input and stuff like that. It's like a huge mess. And this was the first thing we wanted to get rid of. You can only do this optimization if you're absolutely sure that nobody can change the data structure you're caching. Like if even users could like access the DOM nodes directly and put some custom properties on there, and we would have no clue of them. So these would leak into other places, which is pretty bad. You do not want to have this in a framework. So yeah, we got rid of it, and it was a huge accomplishment. And it got rid of quite a lot of code, which is also nice. So another technical debt issue we had is adjacent text nodes. So we had this optimization. The whole point of a virtual DOM framework is to save DOM operations, like to do as few DOM operations as possible. I mean, reading is often quick, but sometimes it can be slow if you have a layout property. And creating DOM is the big issue, like it takes time, so we do not want to touch it often. And one optimization we had is like if you have like multiple texts next to each other, we would join them together into a single text node. So in this scenario, normally you would create one text node for hello, one for your name and one for the bang. And we would just join the nodes together to a single DOM node, so we can just do one append operation. But the big trouble with that is that it's pretty hard. You have to prove that the next node is actually a text node. So you have another if case just for checking, is the next node actually a diff node, a text node? And this is complicated even more once you bring fragments into the mix, because now you need to cross over fragments and check, well, is the first child in a fragment? Is it a text node? Which is, oh my god, it's ridiculously complex. Yeah, thanks. So we got rid of that too, and we just replaced it with just keep the text nodes. Like the savings in memory are not worth it, and it just removes so much complexity from our code, so many edge cases. It just wasn't worth it. So we now can just diff each element directly, and we do not need to check like what is the next node or anything like that. We do not have to do these lookaheads. All right, special error treatment. A fun story. This is also a pretty bug we had in Preact 8. It was there for a long time. And this is, if you had like, there's usually code, you have an array and you call .map and create some elements. And maybe you have like two scenarios where you're doing it. In this case, it just renders 2 pointless diffs with some letters. But you can already see on the right side, which is the code that we would have rendered in Preact 8. And you can see that the keys, they clash. So the keys are a very important optimization. Any diffing framework like React or Preact or whatever you have, or even Vue.js. The thing is, like, you have to know if you have an array like, has my child just moved, or do I need to recreate it from scratch? And just moving a child is a lot cheaper than having to recreate it from scratch, because it could be n times deep. You don't know the depth of the node, so you have to be very careful about that. And optimization we do is like, okay, we just swap them. And to be able to do that, you need to know which element corresponds to which, because you just have a list of DOM nodes. Like, I don't know, like, did the position change? They're both just diff nodes. And we do this by by adding a special property called key, which is basically just an identifier. And we put it on our virtual DOM nodes. We can just say, oh, this one with the previous ID of A has moved to there. But the problem is in Preact 8 it broke in this scenario, because now you have clashing keys. So you're saying, okay, maybe you would have moved the A into the other position, maybe in the first run. So we ended up in scenarios where the DOM nodes were swapped, which is pretty bad. So not a good case to have. So, but the funny thing is, in Preact X we don't have this problem. And the funny thing is, whenever we encounter an array, if you call like persons.map and return like or a list of elements or something, we just wrap it with a fragment. And because they are not at the same depth anymore, we don't have any clashes. Which is really cool because it's just one thing. We just check if we have an array, add a fragment node. That's it. It's pretty much no code, which just comes for free. And you can just pretend like everything is working as usual and just push it through our code, which is pretty great because it's another edge case we have removed and another bug that's now finally gone with X. So the funny thing is, without features, you see like a big decline. Like 8.5.2 was the last stable version of Preact 8, and we started developing Preact X in parallel. And without any features, Preact was actually like, for the longest times during the X release cycle, Preact was only about like, I think 2.4 or 2.6 kilobytes, a lot less than 3 kilobytes. It was only after we added all the new features that we got back up again to 3.6 kilobytes. So meaning it is possible to go below 3 kilobytes. But this is really tough because now you need to skip on some features and everybody would get the pitchforks out. So we can't do that just right now, but hopefully in the future. So what led to the size increase? The main one is hydration. We had to talk like previously with SEO is like server-side rendering is very important for to get your site running up quickly and for Googlebots. And like it was a bit broken in the previous versions, like even before the alpha phase. So we sat down and it actually took us quite a bit of code to get it right. So yeah, a little bit size increase due to hydration, which is basically when your site boots up and takes the DOM that is rendered from the HTML, and we just say, okay, now we need to make it interactive, like adding event listeners and stuff like that, which is, yeah, this is typically called hydration. And the other one is the new create context API, which is basically a pub/sub solution, so you can publish some state and subscribe to it somewhere down the tree, which is just the previous context API was a bit broken, because you could effectively block updates by having a should component update in between, where you could say, okay, I don't want to update any further, but the thing is context needs to update its child. So you could bail out of the tree and lead to incomplete state renderings, which is pretty bad. So there's this new API which kind of fixes that, and it takes quite a bit. It takes quite a toll on size. So yeah. It added a little bit, but in the end we're still at 3.6 kilobytes, so yeah, it evens out. And we also have to talk about future time savings, because future size savings, because there's a lot of things that we can do in the future to make Preact even smaller and make it more ready to add new features. Because the thing is, if you're adding new features, you have to take something away to stay at the same size. So you have to this constant struggle and battle between like removing technical debt and adding new features, which is not easy. You cannot just say, oh, we're just adding features all the time, because otherwise our size would balloon out of control. We have to be very careful to also, once we add a feature, we always look at another place where we can take something away. So we do not have separate time slots. What we do is we always work in parallel with both philosophies, which is very, very important. Like it's a thing like an enterprise. You always have to add new features, and there's never time to kind of refactor a little bit. Like this is also one of the reasons enterprise software is so complex, because if you can never clean your house, like of course it will get dirty after a while. So yeah. What can we save here? This is the whole Preact source code. It's a bit blurry. I apologize for that. And in the red boxes, we can see the classical class API, meaning like a component will update, component should get snapshot before update, should component, whatever. So if we can remove that by bringing in hooks into core, we could just basically delete all this code. And you already see visually this makes up for a huge portion of our complete application code. So the thing is, we cannot remove it right now because we're in the transition period of having both the class API and the hooks API. And there are too many third-party components out there on NPM. And if you would remove that, everybody would scream like Preact is broken. So we cannot do it right now, but this is something we can keep in mind for the future. Or maybe we could even offload it into an add-on, which you need to like a polyfill of some sort, which brings back those features into Preact. And funny thing is, just the hooks API is only 900 bytes, and currently a few other team members have gotten it down to 700 bytes, and we'll see where we end up next. So having hooks in core in 3 kilobytes is possible. We just need a little more time to do it. All right. Where could we save even more bytes? I'm not sure. Does everybody use this feature? Like setting a style property and not adding a unit? Like not adding pixels, not adding EMs or REMs or anything? Oh, there's one user? Oh my god, shit. But I've been poking Jason, to the inventor of Preact, to remove it like on every week. Like, can we remove it? Can we remove it? Is the time now? But it looks like there are still users there, so sorry. We have to keep it in there. Because the regex doesn't compress really well with Gzip, because it's like strings don't compress really well, because you cannot reuse them. So yeah, this whole feature is up to 100 bytes, which is a lot. If you think about 3 kilobytes as your limit in typical application codes, this wouldn't matter at all. But in our case, it's very, very important. And we could save theoretically about 100 bytes. And the other thing is the new context API. It has this weird feature. I personally have never used it, but some people told me they rely on that. Is that you can have you can provide a value. Think of like a theme where your first theme is foo, and you can actually change the theme somewhere down. Or maybe you have like a sidebar which needs to be rendered in a dark theme, and your main side has a light theme, so you just want to change the sidebar. So you can nest the context. But this is pretty bad for size savings, because this feature costs us a whole whopping like 150 to 200 bytes. It doesn't come cheap, which is, if you remember the previous slides with the graph there, this is one of the reasons there's a huge mountain there at the end, which is the create context API. So who uses it? Who nests context? Anybody here? Any React users? Yeah, you again? Oh man, we have to talk. No, all good, just kidding. It's perfectly fine. Yeah, we won't remove it anytime soon, so no worries. But it's just something we keep in mind, because we always check like the whole code base, like, could we move something? Could we remove here something? Could we change this code, and etc. So yeah, let's come to the last part of my talk, which is the actual code golfing. It is kind of a sport in our case. Like code golfing is kind of like chess in a scenario that is not really a true sport, in the sense that you're working with your muscles, you're working with your brain. And the main idea of code golfing is to do the same thing. Like you have an example program or a simple little function which does just one thing, and you want to do it with as little characters as possible. So this means you have to know the environment your program is running. Maybe you can reuse some feature from the DOM. Maybe you can reuse something from the event system or anything like that. So, or maybe you can reuse some other things. And so this is a really, like, we're obsessed with it. And we always have little challenges in our team, like who can do this piece smaller, or this section of like, I have a new PR. And we always have like a sad smiley when it adds too many bytes. And whenever we see the sad smiley, everybody else from the team jumps in and says, okay, maybe we can do this and that. And then we will save like 10 bytes. And then the other one comes in, if we do this on top of that, we can save even more 5 bytes. And so little piece by piece, we can cut down a whole PR in size, which is amazing. But it takes a bit of time, like it won't happen instantly. So one example you can do is, normally compilers would do many of the code golfing for you, but JavaScript is a pretty tricky language because it's highly dynamic, so it can't do everything. And one thing that we do is, it's amazing for Gzip compression, is to store object properties in a variable. So instead of all of calling mask and the square of it, and because there's a dot in between an object access that is a lot bigger than just one character, if you think about Gzip size, we can just store it in a variable and just call it always again in a function. It doesn't save much, but it saves a little, and we don't have many places where we use it. But one piece is where we destroy DOM nodes, or where we destroy a component, and we just reuse the same variable over and over again, so that we do not have to declare multiple variables, which is just a little optimization you can do. I'd recommend it not doing it in an application. It's more of like a library thing, because it makes the code a little bit less readable. So always have like to trade readability for code golfing most of the time. So another thing, every linter will scream at you. But the thing is, you can replace the right-hand side with the left-hand side. Most linter presets have like you need to do 3 equal signs or anything for good reason, because it's easier for newcomers. There's no the left side could lead to typecasting errors if you're not sure what you're doing. Like in this case, it's fine, but if you're comparing a string or anything, like it leads to weird casting errors. So don't do that. But if you really know what you're doing, you can save like a condition there, which is also nice, because we have lots of if this thing is empty checks in our code base, and these all add up. So yeah, another thing, we're not using classes. Kind of funny thing. They're shipped with ES6, and the reason for that is that we're still supporting IE 11 natively. So if we downtranspile classes, you would have all these Babel behaviors like inheritance helper, or it checks if you really have called super in a class, if you extend on it. But in this case, we already know how our class is going to be used. We know who will extend from it and stuff like that. So we wanted to remove all these Babel helpers. And so we just wrote it in the classical, or in the old way of ECMAScript 5. One funny thing is at the bottom with the render function, Preact works, you do not need to define a render function, which is different from React. And the funny thing is, we thought, oh wait, so we need some sort of default render function, right? If you do not define one, if you do not declare one. So we just like, well, we can just reuse a fragment, right? It just returns children directly. The fragment is just a function where you return props.children, that's it. So why don't you just reuse that? So which is also another strategy that we use. Like we have this toolbox in our code. Maybe we can reuse something before we write something, a new piece of code. And this is one of the instances where it saves some bytes, which is nice. Yeah, and this is our ref implementation. This is kind of hilarious. It's just an object. The thing is, we know our user base pretty well, and normally if your refs are there, if you want to get a reference from a DOM element, so you add this property ref in your JSX and you get back an object with the current property. And when the DOM element is there, you have like a current property, which points to the DOM node. If it isn't there, it's normally null in React's case. But we know everybody just writes if ref.current. They do not write if the ref.current is equal to null. We can just skip the current property, just have an empty object, because if the property doesn't exist on the object, it will automatically cast to undefined. So if you have a check like if ref.current, it will just work, because you're not explicitly checking against null. It's just like if you're coming from a type background from Haskell or anything, it's like a huge violation of types, but we know our user base, we know them pretty well, and nobody has bothered us, like said, oh, this is a bug. Oh my god, they're quite invasive. Nobody has bothered to make an issue or anything, so for years, like we have the thing like, I think for a year now. So I guess it's fine, we know our users. Yeah, and so in summary, what I want you to take away from this talk is you cannot optimize if you do not know your system. You cannot optimize your system when you only know pieces of it, when you don't have the whole picture, which is a classical failure in enterprise systems. Everybody only has their system and nobody knows how the whole system works together. So everybody is optimizing their own silo kinda, but it's a mess and they don't work with each other. And sometimes local optimizations can hurt the whole system. So this is, you have to know the whole system to be able to effectively improve the code architecture, which is very, very important. Which is also a funny story, like whenever I'm typically a consultant right now, and whenever I come a new project, it's like, okay, they've explained to me what their software does, and like in theory, like the business case, but how really does it work under the hood? And so they start like scribbling something on a whiteboard, and then the other user joins in, like after 10 minutes, they think like, okay, that's a black box. Nobody knows how this piece works together. And so they're thinking there, all right. Right, and in the end, it's like kind of hilarious for me to see, because they just wrote the system. Like nobody else was there. It isn't a legacy system. It's a new system they wrote from scratch, and even the programmers working, you don't know how it works. Like, how can this ever become a good system? Like, it's not possible. You have to know your code, and normalize all the things. This is the one where I was talking about having a clean core and trying to normalize your data structures at the first step before you work with them. It's once you try it out, you'll see the savings immediately. It's something everybody can do in this room. Just try it out and you'll thank me later. And of course, simple is not familiar. It's for me, especially coming from enterprise background. Many people confuse the two, so very careful. And above all, avoid local optimizations, because this can really hurt the system as a whole. Only do local optimizations like for your single microservice or anything if you have checked against the whole team or against the whole architecture, if it makes even sense to do it at this place and not at some other microservice or anything. So yeah, this is my talk. Thank you very much for listening, and you can follow me on Twitter. I tweet a lot about Preact, React optimizations, Chrome developments, or anything JavaScript fancy. So yeah, thank you so much for coming here.